Hey, this is OXDF, and today we're doing Advent of Code 2023, Day 20, Pulse Propagation. And so we're going to get a list of nodes. It's going to look like this. And so the node is going to have the node at the front and the outputs of the node after the arrow. There's three types of nodes, although I think I guess there's four types of nodes. There is a button node, which is not even going to show up in the input. It's just implied to be there. And the button node, whenever I press it, it sends a low pulse to the broadcaster node. My input will have exactly one broadcaster node, presumably. The broadcaster node receives an input from the button, and then it sends that same pulse, always low, to all of its outputs. Now, here comes some more interesting nodes. There's a flip-flop, I keep calling them nodes, module. If it starts with a percent sign, it's a flip-flop. And what flip-flops are going to do is it's going to have some memory, and the memory is going to start as a zero. I'm going to call lows zeros. And whenever it receives a pulse, let's say wrong one, flip-flops, if it receives a high pulse, it does nothing. And if it receives a low pulse, then it flip-flops between on and off, and it sends out its new version. So if it was off, it receives a high pulse. Oh, sorry, it receives a low pulse, it becomes on, and then sends a high, sends a one. And then these other ones, conjunction modules, they're going to remember, they're going to keep a memory state of all of their inputs. So I'm going to need to figure out all their inputs. All of them get initialized to 0. And then whenever they get a pulse, they're going to update the memory for that input. And then if all of the remembered things are high, it sends a low. Otherwise, it sends a high. So most of the time, it's going to send a high, but sometimes it will send a low. And then they kind of show, so we're going to propagate things using a queue. So basically, when the broadcaster sends things to A, B, and C, all three of those pulses are going to get, so A is going to handle that and send something to B, and then B is going to get added to the end of the queue here. Then B is going to send something get added to C, C is going to get added to the queue here. Then C is going to send something to INV, so INV is at the end of the queue. So now we have B, C, INV here, so then the B is going to go adding another C, C is going to go adding another, anyway, so it's going to propagate through. But we're going to queues, I mean, we've used queues all through this season, so we'll be fine with that. What we're going to do is we're going to push the button, and then we're going to wait for all the pulses to finish, and then we're going to push the button again until we push the button 1,000 times. And we're going to track how many high pulses, how many low pulses are sent, and we're going to multiply those together, and we're going to get an answer. And that is our input, or our result, or our answer. So let's grab this. Let's jump over to here. My Genday script is in the repo. There's a link in the description here to that repo where you can see it, but it basically pulls the input, creates a stub for me. It does not pull the example text. I'd love to figure out how to do that one day. Let's take a look at the input. The one thing I'm very curious to know about on the input is if I do cat input.text into grep -v to remove lines, -e for one option is it starts with a %, -e for another option, it starts with an ampersand. What do I have left? Just broadcaster. Okay, so I don't have to worry about every module starts with is either one of these two things or it's the broadcaster. So that's good. We've only got 58 lines, but I mean some of these things send to 4 or 1, 2, 3, 7 outputs. Anything else I need to know? I guess not. Only one broadcaster, that's good. Let's go ahead and start working on this. This seems like a great time to use a class. So we're going to say class module def under init. To init a module, we're going to pass it a line. Let's grab something interesting, like one of these ones from the input here. What that's going to look like. So that's our line. So the first thing we're going to do is we'll say like, let's see. We're going to split this line into two things. The first thing is going to be like a type name, and the second thing is going to be the outputs. And that's going to be equal to line dot, let's strip it just to be sure, get rid of new lines dot split on space, arrow, space, like that. Now, we're going to have different types of nodes that we need to handle differently. So if type name is equal to broadcaster, I hope that's right, then self.type is going to be equal to, make it a type B. Self.name is equal to, I guess we'll just call it, type name, self. What else do we need to track? We need to track the memory. So in this case, We're not going to have memory here in a broadcaster, but I'm just going to set it equal to none so that we have something there just in case we ever try to reference it. I think that's, oh, the other thing we need self.outputs, and that's going to be equal to outputs dot split on, it looks like comma space. So that looks good. Now we can do an elif type name sub 0 is equal to percent sign. So now we have a flip flop, right? So we can do self.type is equal to f, self.name is equal to, so this will be type name of 1 onwards. So we'll get the rest of the name. We'll do self.memory equals, and I forget, what do we, a flip flop is going to initially be off. So we'll say is equal to 0. And self.outputs is going to be exactly the same. I think it's going to be the same for all of them. So we're just going to grab this and put it there. All right, so elif type name sub 0 equal to ampersand. So we have a conjunction. Now we could have just done an else because we verified they all start with one of these 3 things. But I like doing, just in case something messes up, we can always do an else assert false, knowing that if we ever get there, we want to fail and know about it. So self.type is equal to conjunction, self.name is equal to type name 1 onwards, and self.memory. Now self.memory for this, we have to track all of its inputs. And we don't know its inputs. Like when we get the first one, we haven't even seen the other things yet. So what I'm going to do for now is just initialize it to an empty dictionary. And we're going to have to come back later and fill that in. I think we're basically done with what we need here. Before we could test this, but to test this, I think it'd be easier if we just do another class. So we're going to do class system. This is going to sort of represent our system. So we'll def under init. And system is going to take lines. We probably should type hint this, which is going to be a list of strings. A line is going to be a string. Oops. That's the wrong spot. There we go. So that looks good. Now what we're gonna do for a system? Well, this is where we're gonna track things. So we can definitely track things like self.high equals 0, self.low low. I like low or low. I'm probably gonna go back and forth. Let's keep it to 2 characters. Self.modules is equal to that because we're gonna need the ability to pull a module by its name, and so we're gonna keep a dictionary where the name pulls the module. So now we can say for line in lines, module equals module of line, and now self.modules of module.name equals module. I think that should be all we need to save that. So now is where we can process the output. So we can say for module in self.modules.values, because we don't care about we don't need the name, we'll just get the values. What are we gonna do? So for each module, let's go over the outputs. So for output in module.outputs, and then here we're gonna say if self.modules.output, because outputs is just a list of module names. We're going to get it from self.module. We'll get the module dot type is equal to C. So if we have a conjunction, if the current module that we're looping over outputs to a conjunction, then we'll say self.module.output. Probably a cleaner way to do this, but I guess we could say like output module equals self.modules output. I don't know if it's actually better, but we can do output module and output module of output. And then what do we need here? So we're going to say that we're going to get the memory. And then that is an empty dictionary right now. Or yeah, an empty dictionary. So we're going to put in there module.name. We're going to initialize it to 0. I think that looks good. Now let's create a system. So we're down here, we'll say system1 is equal to system lines. And let's just give that a try. We'll do Python -i so we can play with it. Day 20 example. We have a problem. Module is not subscriptable. Oh, output module. That's not what we wanted. We don't need the output here. There we go. Output module.memory. That looks better. That worked. Let's see. So what is system1? Not useful. System1.modules. This is still not going to be useful. We're going to need a repr. Oh, so we can see we have broadcaster A, B, C, and imv. That's looking good. Let's make this a little pretty. Let's make this a little prettier. Def repr. Not in? Oops. Def repr self to string, and so we're going to return f. We're going to say module, and let's say self.name, maybe self.type, like that. Colon, maybe self.outputs, and I don't know. We'll try that. See if that works. System.one.modules. There we go. So we can see we have B going to A, B, and C. We have A going, which is a flip-flop going to B. We have B, which is a flip-flop going to C. We have C, which is a flip-flop going to M. We have M, which is a flip-flop going to A. Looks pretty good. We'll test that a little more complicated. Ooh, we got a failure. I was not expecting that. I was hoping to just see a kind of a cooler thing. Rx is not a module. Check it out. Rx. Okay, so Rx is some sort of like exit point where it never is not actually a module. It's a little scary to do, but we can do something where we say if output not in self.modules continue. Hopefully this doesn't screw us up. Let's see, len self.len. How many do we have there? 58. Okay, so we did get all the modules. Okay, that's probably okay. We'll continue from there. So now we got to push the button. So we're going to be within here. Def push self going to none. What happens when we push the button? We're going to come back here later and add like an n, but for now, we'll just start here. So we're going to need a queue. And for a queue, we're going to use from collections import deque, as we've used many times this season already. So queue is going to be equal to, let's think about what our state's going to be. So we're going to need to know the source module, the source that's sending the. We're going to track. Our queue is going to be tracking pulses that are going across the wire. We're going to send a pulse. The pulse to be sent, I guess. We need to know the source. We need to know if it's high or low, and we need to know the destination. So our queue is going to start with, when we push the button, we're going to start with this tuple that is going to be, we're just going to call it button as a source. It's going to be a low pulse, and it's going to be going to broadcaster. And that is the name we set up here for the broadcaster right there. So that'll work. Now we can say while queue source pulse and desc name is equal to q dot pop left. We'll pop up left and append to the right. Now we can say if pulse equals 0, self dot low plus equals 1, else. We're always going to assume the pulse is going to be high or low. Self dot high plus equals 1. We've now sent our pulse. We will say module is equal to self.modules desc name, like that. Seems reasonable. We get the module that's going to. So we've sent the pulse now. The module's been received. We just need to figure out what else goes on the wire, right? So we'll say if module.type is equal to B, then for output in module.outputs, q.append. And what are we going to append here? So the sending one will be module.name. Are we sending, I think, that will be fine. The output type will be whatever the pulse is, whatever it was. And the output will be output, the name of the output here. So these are all strings. That looks good so far. We haven't used, so okay, that looks fine. Elif module.type is equal to f. So f, what do we do? I guess we only do something for a flip-flop. If it receives a high pulse, it does nothing. If it's a low pulse, it flips its memory and sends out that value. So we can say and pulse equals 0. We only want to do this if pulse equals 0. We'll say module.memory equals, and now what's the best way to go switch between 1 and 0? I think it's going to be not module.memory and then convert it back to an int. It's kind of sloppy, but we can go with that for now. And then we can say for output in module.output. I wonder if this loop going to be the same for everything. I think so. We might be able to consolidate this. I'm gonna leave it for now. Q.append module.name. The pulse is going to be module.memory, and the output is going to be output. Okay, that looks good. Elif module type is equal to C. And on this one, we don't get to do the and blah, blah, blah. We're gonna do something no matter what. So we're gonna say module.memory. So we're gonna take this is the destination memory. So source is equal to pulse. Next pulse is going to be 0 if, I better look this up. Going to be 0 if all of them are high, otherwise it's going to be 1. Okay, so if all module.memory.value, and because of the way we did high, we can just sort of say if all of those things are 1, if all of those are high, then this will be true, then we send a low. Else 1. So now we can do, and I am going to do this. Oh no, we can't. Well, we could do something like elif module type equals f if pulse equals 1, continue. Now I can get rid of this. And now we can get this loop. What I wanted to do is get this loop out of here. So we can put this loop down here. What would I do? We can come down here, and no matter what, we're going to say for output in module.output q.append module.name module. Oh, this will be next pulse, and this will be output. And here we already set next pulse, so now we just need to set next pulse here. Next pulse is equal to module.memory. Get rid of you. And here, next pulse is just pulse. Next pulse equals pulse. Okay, so what we're gonna do, we're gonna get the module. We're going to, if it's a type B, we're gonna send the same pulse through. If it's type F and it's a high, we're gonna do nothing. So we're just gonna continue. That continue will actually loop up here to the next thing in the queue. If it's not, we're going to update the memory on the flip-flop, and we're going to then set next pulse to that. If it's a C, we're going to update the memory for that source, and we're going to set the next pulse here, and then no matter what, then we're going to send out these pulses by putting them in the queue again. And we might be, I feel like we're in okay shape here. Let's do this. Let's call here, we'll come down and we'll say System.push, and see what we get on the example. Let's see, okay. Module output, what line are we on? 73. Yep, that seems reasonable. Okay, so what if we do system.high, system1.high, push 4 times, system1.low, pushed 8 times. I think that sounds right, actually. In the first example, the button 8 low and 4 high are sent, so after pushing it 1,000 times, it's 8,000 and 4,000. All right. Let's see, what's the other one? It doesn't tell us after one push on that one. So let's go through and add multiple pushes now. So push n for south, we'll say n int equals 1,000. And we're just going to basically loop this whole thing in tab for underscore in range and do that. So now if we run this again, why don't we just go ahead and do part 1 is going to be system1.low, system1.high, make that a tuple so we can get both values. Get there, and now we see 4,000, 8,000, which is what we wanted. Let's try the other one. Where's the other example? We need the more complicated example. Here it is. Oh, shoot, I control C. Okay. We don't need the dash I anymore. And we are failing here. Key error output. Oh, we have another example of, let's see, where are we? On line 63, we have another example of a key that doesn't quite exist. 63. Aha. So if we try to send it, if we send a pulse to a module that doesn't do anything, we still need to send the pulses, but then we can just say if dest name not in self.modules, continue. We'll just be done. 4250 and 2750. Where are my lines? 4250 and 27. So we're looking good here. We're going to multiply those together to get an answer. So let's come down here. Times. That works. This is not even that long. Grab this. Sweet. On to part 2. Okay. So I've read part 2. I also cheated a little bit and went ahead just to say I'm going to assume, because this is part 2 on day 20, that I can't just change my loop into a while and run it for a while. And it ran for 2 or 3 minutes, and I decided this was clearly not the answer. We're gonna have to think about it a little bit more. And so we're gonna jump back over. So let me come back here. Part 2. We need that module Rx, which actually came up because we noticed it has no outputs, right? It's just an input. And so we are waiting for a single low pulse to get sent to Rx. And so we're going to reset the default states, and we're going to wait, do the same thing. How many button pushes are required to get a pulse to Rx, a low pulse to Rx? And to do that, we're going to need to think this through. We're going to need to do some kind of experimenting, right? Because I don't think this has just a generic solution. I've been thinking about this for, it just went and I was here, but I thought about this for a while. So what are we going to do? We're going to do system2 equals system of lines. Get ourselves a new system. We are going to do system2. Okay, so we need to think. We need to do some thinking about what this looks like. So what's coming here? We're going to look for Rx, and we can see it is coming. We're going to get that thing from Bn, and Bn is a conjunction, right? And so conjunction is we need a low pulse. That means we need all the inputs to Bn to be high. So if we look for space Bn, we can see Bn has 4 up here on the right. It might be on my face, but there's 3. It says out of 4. B has 4 inputs, and those are all conjunctions as well. So we are going to look for what I think our answer is going to be. We need to look for the cycle. There must be a cycle in here, is the assumption. And if we have a cycle, we can figure out when do each of these 4 nodes send high to Bn, and then when Bn is high from all 4 of them at the same time, that's when it's going to send low and we win. So if we can get the cycle time on each of these, we can find the least common denominator and get the time when they'll be lined up. To test that theory, let's do some experimenting. So we're going to come in here. We're going to say lines for system2. So now we can say for module in system2 dot value dot module dot values. Let's get all the modules. If rx in module dot outputs print. We're going to formulaically do what we just did kind of manually. Found module that feeds rx module dot name. So we can see, they didn't give us any example input for this one. We are just going to have to work off the puzzle input, and it doesn't help us because there's no rx in any of the examples here either. So okay, so we know bn is the one that leads there. We can look at that for module in system2.modules.values. We can do the same thing to look at that. So we'll say if, we'll save it here. What do we call this? 2rx is equal to module. If 2rx.name in module.outputs print found module.name module.name input to rx.name. I don't know if this actually makes any sense. Let's give it a try though. Okay, so we have bn feeds rx, and then bn gets things from pl, mz, lz, and zm. Okay, so the question is going to be, let's track these nodes. So we'll say like, well, actually, let's just track, we got 2rx, let's track that. So what we can do now is, let's do system2.push. I'm going to say debug equals 2rx. We're going to pass in the node we're looking for. Now, up here in our, where's our push? We'll say debug equals none. So by default, there's no debug, but I'm not going to type hinting that. So what are we going to do? We want to know when a pulse is sent to our node. So we want to know when pulses get sent to bn. We want to specifically know when when high pulses get sent to bn. So here we can say, I guess this is as good a place as any, if debug and dest name is equal to debug, which make sure this is a name. Okay. If that print, let's just try this. Sending pulse from source to dest name. I think this is going to be really loud. But let's try that for a second. This is really loud. Okay, too loud. Okay, but now let's just say and pulse, because we only care when the pulses are high. I think that's right. Yeah, because look at all those zeros. We don't need the word count anymore. Sweet. Okay, this is making progress. We're getting here. At push I. See if this works. Let's make this an I. We're not getting any. Oh, we're not getting any. Let's change n equals 10,000. help? Oh, we did. Okay. Interesting. So there's a couple things to note here. Right away, it jumps out to me that LZ is getting it 4002 and 8005. Bet you if we do, where's my debug? I plus 1. Because we don't, this actually was on push 0, and we want push 1, right? Yeah, so look, 4003 and 8006. Also up this to 20,000, just so we can see a few more. Grep, which one was I looking at before? 4,000 is LZ. So LZ it's happening every 4003. That is a cycle. That is awesome. Similarly, we could do on ZM, we can see that, at least see the 3, 6, 9, 12, 15. Like this looks like it's a cycle as well. So if all of ours are happening on cycles, literally what we just need to do then is, if we wanted to cheat, we could do part 2 equals math.lcm, I believe it is. I better import math. Import math. Is it LCM or is it greatest common denominator? Least common multiple, yeah, LCM of, let's see, can we give it 4 values? Bet you this solves it. It'd be fun to come back through and, well, I guess I shouldn't get cocky. Let's see. Let's see if that solves it. We should. It did. Sweet. So what we did was we found the cycle times there, and because then we can find the least common multiple, which is going to be the first time that all the cycles line up at the same time, and that's going to be our answer. It would be interesting to add some code to this to have this find these cycles and then not just hard code them in here. I might leave that as an. All right, I couldn't leave that undone. It's too ugly. So we're gonna do it. So how are we gonna change this? We're no longer gonna track. We're not gonna pass. We need to track the cycle time for each of these 4 things, right? So we'll say p mods equals that, and now we can say p mods dot append module dot name. Okay. Now we're going to change our thing here. So we're going to say system2 is going to return cycles equals. We're going to get that out of this push function. And we're going to leave, again, we're not going to make it super generic where n could be, we'll just have to make n great enough kind of manually. We could do like a while true, but we're just going to leave it for now. And so we're going to change this to p mods equals p mods. Okay. So we come up here now to our thing, and we're no longer going to have key mods. We'll have key mods. What we really want is key mods to be a dictionary. A dictionary? Yeah. A dictionary. So we're going to key mods submodule name equal to none. We're going to pass it in here. I wonder if we can pass by value. Does that work? So we come up here. We have key mods equals none by default. So now we have if key mods, and it's no longer going to be dest name equals that. It's going to be if the key mod sends, so it's going to be a source in key mods. If source is in key mods and the pulse equals 1. So if we're sending a 1 from one of the key mods, we're going to print that out. Otherwise, we're going to continue. Let's run that and see if it works. Same result. Okay, so we're still good. And our pushes still look the same. Yeah, 4003. Yeah, so we're still good there. Okay, so we're still triggering in the same spot. So now what we're going to do is we're going to say, when we get down here, we print it, but we can also say key mods sub source is equal to I plus 1. Now my question is, does this, when I get to here, is key mods updated? Key mods. It is. Cool. So I actually don't need to return here. So now we can do math LCM. Let's see. Let's comment you out and do part2 equals math.lcm of key mods.values. And we just want to put a star here to spread that out. Now we run this. Let's see. Exit U. Don't need to be in here. Oops. Oh no, I didn't mean to exit that. Let's open up this cd day 20 python day 20 input.py. Was that our answer? Did we still get it? Wow, I didn't even realize until just now that they're not in order this year. Let's see, is that, no, we got something different. So that's oh, because we're updating it constantly. That's not right. So once we need to do, so we'll do if not key mods source, then we update it. And then we can also really do if, let's see, all v for v in key, I guess we can just do key mods.values return. And that runs even faster because now once we hit all 4 of our cycles, we're done, and that looks better. Let's see, was that our answer? 225514? 225514. Sweet. So now we've got something that works for part 2. If we send in, we've kind of bastardized our push function here because we on the one case we run 1,000. We really might want to do. We could do something to make this cleaner, like not push an n here. We'd make this a I equals 1 while true. We come here and we do push n equals 1,000. Now we're just sort of cleaning this up so that now we come and say, while true, run the whole thing, I plus equals 1 if I is greater, if n and I is greater than n, return. Does that still work? Let's get rid of my print statements here. Now we're really just fumbling around. I'm not sure this is actually valuable or not. Whoa! None type cannot be found as an object. What did we do wrong? Oh, because we didn't run enough. And none. Now my type hinting is just confusing me. So there we go. That does not look right. Is that right for either of them? 825. Yep. So we're still in part 1. We're not right in part 2. Would have expected part 2 to actually be the part that worked okay. Save you and run you again. I'm not going to go too long on this. We are just getting, because we are now 1 based. That's why we're off. So that looks right. So there's some final code. That's better. It's still kind of an ugly function here where we have like an n or a key mods and we pass one or the other. But it works. So all right, I'm gonna call it here. Thanks for hanging out with me today, and I'll be back tomorrow. Bye.